Our project is Planta-Arca, which is an IoT-based smart plant monitoring system. And here is our team. Plants play a vital role in maintaining the ecological cycle. To maintain a plant's proper growth and health, some external factors must be tracked constantly. With today's technology, it is possible to do all the tracking with an IoT-based smart monitoring system, which is Planta-Arca. Planta-Arca is able to monitor light, humidity, temperature, and soil moisture levels of plants with the provided sensors. The system also encompasses a mobile application through which users can remotely monitor the measured sensor values and on-off lights, water pump, and fan by pressing the buttons in the mobile application. And our main goal is to provide the ideal condition to a single or many plants. Hardware and software used. For hardware, we used ASP-ROM32D. It is a powerful microcontroller which is also Wi-Fi and Bluetooth capable. We used DHT11 digital humidity and temperature sensor, which is one of the most common digital temperature and humidity sensor used in many projects. We read the corresponding values with this sensor and send them to mobile app. YL69 soil moisture sensor, again one of the most common and preferable sensor of its kind. YL69 is capable of sending high and low values according to the situation. We use it by sticking both ends of the sensor to the soil and send values to a LED in our mobile app. We use photosensitive light dependent control sensor. It is a basic control sensor that is able to determine if the area around the sensor is lit. We also used custom built LEDs, Mark-Slow fan, a brushless motor submersible water pump, and motor driver. For the hardware. For the software, the system basically evolved around Arduino, ASP32D, and Blink software. Code implementation. Here is our Arduino code. I'm going to explain this basically and quickly. In here we define Blink print serial, Wi-Fi hash, Wi-Fi client, Blink simple ASP32, and the HD sensor. We have the authorization token taken from the Blink app and Wi-Fi credential, Wi-Fi name and password. We define digital pins for sensors connected to, and we have integers to control water pump, lights, and fan. We also have variables for Blink LEDs, variables for keeping values of humidity, temperature, moisture, and light, and we have void sensor, which is a function to constantly read those 4 values. And here we have our error messages if sensors fail to read the data. In here we have Blink virtual write for sending values for humidity and temperature to GAUX. And in here we have if loop, LED1 status for lighting the LED1 according to moisture value, and if LED2 status loop for lighting LED1 according to light value. In here we have Blink write V1. This one controls the terminal inputs and outputs. We will explain this detailed in the demonstration of the project. In here we define buttons to control light, pump, and fan, and we will show you how they work in the mobile app demonstration. Also we have the setup function and the loop. And now Mustafa will explain the system design and do a project demonstration.
Hello, this is Mustafa. In a few minutes, you'll see our plant and the plant box itself, but I just wanted to go over our hardware real quick. So you can, like, let's start with the board. You can see that we have an expressive ESP Room 32D board. We were previously using an Arduino Uno with the ESP8266 module, but that wasn't very stable. So we thought, why don't we just go with a board that is Wi-Fi capable? So we chose this one, and we have 3 sensors, as you know. This is the LM393 photosensitive light dependent control sensor. The one that you see here, the blue sensor that is linked to the breadboard, is the DHT11 digital humidity and temperature sensor. This is YL69 soil moisture sensor, and there are of course 3 corresponding motors to those. This is our custom built LEDs. This is like our Mark's Law fan, and this here is a submersible water pump. And to control those, we have L298 and motor drivers. This one is powered by an outside 12 volt 2 amperes power source, and this is powered by a battery, as you can see here. We also have a phone here that controls our system with the Blink app. Our layout is very simple. There are 2 gauges above that read values from the DHT sensor. The one on the left is humidity, the one on the right is temperature. There are also 2 LEDs to check if the plant has access to water or light. There are 3 buttons to control the motors and the terminal that can read values or control motors. We can start trying the lights. So if you remember, the one on the left is the light sensor and the one on the right is the LEDs. So if I were to press lights on, it turns on the lights and the sensor reads that. So the LED on the right side turns to yellow from dark blue. We can do the same thing with the pump. So if we were to press this pump button, it takes water from the right glass to the left one. It slowly starts filling. So if we were to stick this into the water, we can see that the LED on the left hand side turns to blue. It's normally red when the moisture sensor is out of water. So if we were to, like, say H and send that to the terminal, we can see that the terminal returns the value for humidity, or say T for temperature. We can of course say, like, open fan here, so it reads that value and opens the fan. We can of course use it for lights too, so it opens the lights, and we can type in close motors to close all the motors. Hello again. So we were able to set up the system with the plant and the plant box itself. On the backend side, it's really a mess of cables here, but the system stands the same. It's also powered by directly from the electrical socket this time, instead of the computer on the previous videos. So we now have our sensors on this side and inside the soil. So this is the soil moisture sensor, and we also have the DHT sensor on the back right now. We also added, like, the fan and the light to the ceiling of this thing. So just to show you that it stands, we can again turn on the fan and the lights. So you see those are working now. And then if we were to open the pump here, it waters the plant itself. So if we want to again close our motors from the terminal, we can still use close motors command. You see that lights and fan is still on. Now they're closed.